Example 3, page 279, starts out with this lovely equilateral triangle. And for some magic reason, we decide we're going to pick the equilaterals as 2. So we pick each of those sides of the triangle as 2. What are the angles of an equilateral triangle? 60s. Yeah, 60s all around, because they have to be the same and they have to add up to 180. So that's the starting point for this example. Now, the next thing that we do with this is bringing back a term from geometry. We're going to bisect this top angle. So if we bisect it, what does that mean each of the two pieces are? Yeah, they're triangles. That's a 30-degree angle now. And it also means that each of these pieces of the base now are how much? 1. So now we've got a new triangle, this one that we're interested in, right? And I'm going to switch over and redraw it on a new page so that we can see what it is. We've got this triangle. This angle is 30. This angle is 60. This side is 2 because that's what we started with. This side is 1 because we bisected the base, and we're not sure what the height is. And this is a right triangle. It has to be a right triangle because this is 30, that's 60, so that has to be 90, right? We also know that we can do a squared equals b squared plus c squared. That's our friend the Pythagorean theorem from geometry, right? A squared equals b squared plus c squared. If this is a and this is b, then this c over here is how much? Well, we can calculate that. We've got 2 squared is 1 squared plus, c squared. Okay. C squared. So that's 4 minus 1 is c squared. So c squared is 3. 3. That's a 3. C squared is 3. So c is square root of 3. Okay? Well, now we know everything that we need to be able to do sines, cosines, tangents, and all their other friends for these angles. So for 60, sine of 60 is opposite over hypotenuse, right? Now, in your homework or your assignment that you're doing, you don't have to write opposites and hypotenuses every time. You can do O, A, H. We'll know what that means. So what side is opposite 60? Well, that's this one. So that's square root of 3. Hypotenuse is 2. So that says the sine of 60 degrees, or pi over 3, is square root of 3 over 2. If you look at your reference card, the sine of pi over 3 is square root of 3 over 2. The cosine of 60 is adjacent over hypotenuse is, let's just do that, is 1, 1 over 2, 1/2. So for the assignment problems where we're asked to do things like what is the sine, cosine, tangent, cosecant, secant, cotangent, and let's go ahead and do 30 degrees since we just did 60. Well, this is opposite over hypotenuse. This is adjacent over hypotenuse. And this is opposite over adjacent, right? So if we look back for 30 degrees, well, the sine is 1 over 2, right? 1 over 2. That's 1 over 2. The cosecant is just sine upside down, so that's 2. Cosine is adjacent over hypotenuse. Well, adjacent for sine is square root of 3, so that's square root of 3 over 2. And this is just 2 over square root of 3. If you want to rationalize it, that's fine. Square root of 2 square root of 3 over 3 is okay also. And tangent is opposite over adjacent, which is just a half, and the cotangent is 2. So that's how a lot of those problems in the assignment are intended to go.